Hello and welcome back to AGT Sim. Today we're going to be watching a video on Lawrencium. So, without further ado, let's hop to it.
The basement of the Royal Society in London, this is the UK Academy of Sciences, and they have exhibitions here telling people about interesting things about science. And so we've come here because there's a really interesting exhibit relevant to the work of Lawrence, who was the person after whom the element Lawrencium was named after. Lawrencium is another one of the elements right at the bottom of the periodic table, which are really heavy, very radioactive. They fall to pieces very rapidly. So chemists and physicists are very lucky if they just make a few atoms of this. So there's nothing to tell you about the uses of Lawrencium, because nobody's made enough Lawrencium to use it for anything except as the subject of scientific papers and physical measurements. So instead, I want to show you here a piece of equipment which is very similar to the sort of equipment that Lawrence used when he was doing his pioneering work in Berkeley, California, close to San Francisco. So let's go along here. Lawrence was famous for inventing an instrument called a cyclotron, which was for accelerating electrons to very high speeds. It was in fact the precursor of the Large Hadron Collider, which everybody's now talking about. But he thought of it, I think, one day in the library in Berkeley, and he imagined, to begin with, an instrument that was literally as big as my two hands here, a few inches across. And his idea was that if you made a vessel which was quite flat and circular, not very high, and put it in a big magnetic field, the electrons could go round and round and round and be accelerated to go faster and faster. The idea was that he made one and demonstrated the principle, and he patented it, and then he built bigger and bigger and bigger machines. And as he made them, not only did the disk get bigger, but at the same time the magnet got bigger as well. And the final magnet that he made in Berkeley, which was installed just before the Second World War, was so large that a large part of his research group could sit between the poles of the magnet, and it's so heavy that the magnet is still there to this day. But come and look.
That's cool.
Look over here. This is a cyclotron that was built in Cambridge. The first thing that strikes you is that it doesn't look very exciting. It's two copper discs which are not actually connected together, and the voltage is switched between one disk and the other. So as the electron goes round, when it gets to the end of one, you switch the voltage so it goes on being accelerated. And it goes round, and as it goes round in a magnetic field, the faster it goes, the bigger the circle. So it goes round and round and round in a larger and larger circle until the end it flies out of one of these tubes. I think again that it is important to say that some of these historic physics experiments, which are so important to both chemistry and physics, were done with equipment that really looks surprisingly simple. And it is the really clever ideas that have been so important to physics and chemistry, rather than always having enormously complicated apparatus. Sometimes, to take these ideas to their full extreme, you do need complicated apparatus, but that's not the starting point. Well, I've read quite a bit about him. He was meant to be a very egotistical person and a real control freak, but my father-in-law worked in Lawrence's research group. When he was an English undergraduate, he was sent to America during the Second World War to work in Lawrence's group on the enrichment of uranium isotopes, that is, concentrating uranium-235, the less common isotope, which was basis for the atom bomb that was dropped on Hiroshima. So John Keane, my father-in-law, worked in the research group. I don't know exactly what he did, but it's really quite a sobering thought that during the Second World War, some of the brightest scientists had to work on these terrible projects, really in order to save their countries. And let us hope that such things never happen again.
Well, that was actually pretty interesting. Thank you so much for watching, and we'll see you next time. Stay smart. Bye!